All right. Our presentation was on weaponizing data science for social engineering. It was based on the Black Hat talk from 2016. So a brief outline of what we're going to talk about. We're going to look at introduction to phishing, how it works, why using Twitter is a good resource, good playground for phishing attacks. Then we're going to talk about data science, and then an outline of how our program works. All right, so intro to phishing. So basically the goal of phishing is to get targets to visit a link that we control. We're not going to dive into what may be on websites that we would control, but our goal here is to just get somebody to visit a site that we're controlling. There's kind of two basic methodologies. One is more of a shotgun method, where you send out a bunch of links and you try to get targets to click on them. Usually your success rate for those is very low, but since you're sending so many, you have enough targets to work with. The approach that we're going to look at more is the spear phishing approach, where you're sending really personalized messages to people with the hopes of getting much higher success rates. But since you're generally sending less attacks, you're getting relatively the same number of victims. So this is sort of a high-level chart of how this works. If you put in a lot of work, you're hoping to get a much higher success rate for something like spear phishing, whereas traditional phishing attacks have a much lower level of effort and therefore a much lower success rate. So our goal here is to have a low level of effort while still having a fairly high success rate. Talk a little bit about some previous attempts at this. A good example is Microsoft's Tay.ai, which was trained on a neural net entirely from sites like Twitter, Kik, different social networks. Unfortunately, it was sort of a disaster for Microsoft because Twitter is not a great place all the time, so it became really racist, really homophobic. It was kind of a PR disaster for Microsoft.
I think the issue is they allowed it to learn from people responding to it, and that attracted a lot of attention from Reddit, turning her into a big-time Trump supporter.
So these are kind of some of the issues that we're trying to work around here. So why is Twitter a good place to work on something like this? For one, the API is really easy to use. They have a full public API. There's lots of libraries already written in pretty much every language to interface with that API. It makes writing up a quick program really easy to do. A lot of tweets use shortened links in order to fit the 140 character limit. So it's really easy to obfuscate malicious links without it looking strange, since pretty much every link on Twitter is shortened already.
I think Twitter actually now shortens the links themselves, so a lot of the links are t.co.
Yeah.
And some string.
Yeah. And the last big reason is that perfect grammar isn't important. So even though machine-generated text isn't always perfect, doesn't always make perfect sense, neither do a lot of the tweets already on Twitter. So having that machine-generated text doesn't look terribly out of the ordinary. A brief outline of what our Twitter bot, how our Twitter bot will work. The first thing it does is scrape tweets from Twitter. So it'll pull down just kind of a random sample of recent and popular tweets. Then we'll train our neural network so that given some seed text, which will be basically a feed history of a user that we're trying to target, it will generate a tweet that will look relevant and complete to that user. Then we'll look for users to target, and then we'll generate a tweet using our neural net, and we'll append a link to the end of that, and we'll send it out. So going a little bit more into the actual scraping of Twitter, again, their API is really easy to use. There is an endpoint for searching tweets. So we're looking for, you can search by keywords, you can search by hashtags, you can search for tweets that contain links. Our method was to split our targets into different groups. So basically by topic like politics, sports, cybersecurity, science. So we came up with a list of keywords for each of those groups, and then we collected samples of tweets from each of those groups, which we then used to train our neural networks. So now we're going to talk a little bit about the machine learning behind this.
Okay, so we scrape a lot there. We got something like 300,000 tweets, which isn't that much, but still a lot of tweets that are coming from like cybersecurity people. We also got some from sports people, from what was there? Politics
Science.
and science, I think.
Yeah.
And the idea is, with enough data, I can figure out the patterns in speech. I can make something that looks about correct. That turned out not to be as easy because, from what we estimate, something like 60% of the tweets we got are made by bots, and it's not even easy to get rid of them because they didn't use the same tweet over and over. They're just changing a couple of words, and it takes like quadratic time with the number of tweets to get rid of them. So we kind of gave up on that. What we also do is we do a lot of pre-processing. Most, like 90% of the time in data science goes towards pre-processing the data, and then 10% to playing around with the models. Can we get to the next slide? So we have a couple of ways of generating tweets. First way is the old school way, which is we take each word in our corpus of tweets, or in the 300,000 tweets, and each of the words is represented as, let's say, a symbol. And what we need to do is chain a number of those symbols, and we'll get some tweet. What we opted to do is actually model it on a character level, meaning each character is a symbol. That way I don't have 100,000 different words, I get only 40-45 characters, and I need to make longer sequences of characters. Problem is there is less semantics in that, so you need deeper, bigger models to kind of figure that out. Can you get the next
Yeah, I'll also mention our secret code, DEADBEEF, and then that twice.
Oh, did you go twice?
Okay,
all right. So we're using neural networks to generate tweets. Now, classic neural networks work like this. We have neurons in layers. Each of these is a specific layer. Each neuron in one layer is connected to all the neurons in the layer before it and the layer after it. What each of these connections does is it has some weight, and a signal passing through it gets multiplied by that weight. Each neuron sums up those signals, gets its activation, and sends it on. We could talk about this a lot more, but if you're interested, Google neural nets. Can you get the next slide? Now, in order to train neural networks to actually generate tweets, we can't really use classic neural nets. We have to use something called recurrent neural networks, which are basically similar to neural networks, but they add extra connections through time, meaning some neurons will not only get connections from neurons close to them, but will also get connections from neurons close to them from previous time steps. So it looks something like this. I get some input, I put it into the network, and I get some output. That's a classic neural network. What we also do is send the connections to the next time step, and that can be seen in an unrolled fashion as this is the first time step, but this neural network also sends its signal to the next time step, and so on and so on. Problem with them is they're extremely hard to train. One would say almost impossible without some extra tricks. So can I get the next one? Somewhere in the 90s and starting from 2014, they made a comeback. This thing, long short-term memory, or LSTM for short, it makes an alternative model of the neuron where instead of all the neurons talking all the time, making a lot of noise, what we get is this model of a neuron which has specific gates for controlling whether it's going to listen to anybody and whether it's going to talk and whether it's going to keep its memory or forget it. There is a list of reasons, a list of papers why these things work and recurrent neural networks don't. But the point is they're actually pretty good for modeling text. Modeling temporal sequences in general, like stock markets and stuff, but text can be seen as a temporal sequence, and they find that these perform really well. This is an example of how we would actually go about training tweets. So what we do is we take all the tweets and take a random tweet out of the corpus and take the first 20 characters. All I need to ask my neural network is predict me the 21st one. And after it predicts the 21st one, I take the 21 of them and I ask it predict me the 22nd. And I keep training the network to be good at that task. So this is an example of a neural network where I... This is the example of a neural network where I give it the input H, and hopefully I want it to give me the output E. I give it then the input E, so it has seen HE, and I want it to say L. So I would give it hell, and I would expect it to eventually say O, hello. So it has predicted that I wanted to say hello before I said the last character. That's kind of what we're trying. The design space for us is much bigger, but as we'll see, they're gonna figure it out. Can I get the next one? So this kind of approach has been used on a lot of stuff. Andrew Carpenter trained it on Shakespeare texts, and this is the example of LSTM learning how to write Shakespeare. So it says something like, oh, if you were a feeble sight, the courtesy of your law, your sight and several breath, will wear the gods, and so on and so on. So it kind of gets the ye old English, right? It doesn't get the sense of the play, meaning King Lear literally walks into the play, says a couple of sentences, and leaves forever. So it doesn't figure out, okay, you have a finite amount of characters, and they can't all be in this one play. This is an example of an LSTM trained on the whole Linux kernel. So it's learned to write C, and actually that C looks about correct to somebody just giving it a glance. It learns to document stuff, it learns to write comments, it learns to initialize stuff and deinitialize, and learns to... What it doesn't learn is that for you to use a variable, you need to initialize it first. That's like a high-level concept it's missing, and it's just initializes stuff it never uses afterwards, and so on and so on. But this looks like C, and we want tweets that look like tweets. So these are a couple of examples from the cybersecurity tweets we generated. User, it's time to stole the tone, the site, and the accounts, so I can spend the cybersecurity. Like, that doesn't make a lot of sense, but at least it looks human more than the generated ones, the pre-written ones. What I particularly liked is not sure the visual of the Carolesh process and then link. That I might even click on that. Election days patch and the Wi-Fi password is the blacks of link. This LNK are the places we would put our links in. Can you go to the next one?
So going back to kind of the general framework that we had, once we've been able to generate our text, We'll generally search for tweets using a hashtag or some kind of targeting, some kind of method of targeting. We'll collect all the users' recent tweets. We'll pick one of those at random and we'll generate our new tweet from that. And then we'll prepend an app mention and append the link that we want to send to the target. For our implementation, we wrote a command line interface using Ruby, which handles the collection of the sample tweets, as well as the generation of the new tweets. And then, well, this is kind of a general outline of what a run looks like.
We ran the networks in Python. We used Keras. It's a deep learning library by one of the people working in Google. We trained it on a laptop GPU that's kind of old, so it took like 10 hours per network to get anywhere close to the results we wanted. We needed to train separate networks for different groups because I didn't want to mix cybersecurity and sports people. In the results, in the paper, they report something like 30% of the tweets would yield a click for the spear phishing tweets, while the regular phishing attempts would yield something really low, like 5 to 10, and that's optimistic. What we see is that we don't get anywhere close to what we see in the paper. We get something like 20-23% of the tweets get clicked on. Weirdly, some of them get clicked on multiple times. We're postulating they're bots.
Yeah, you can notice when you look at the list of, or the resources or the places where the links were clicked on from, very few of them are actually clicked on from Twitter. So we suspect that there's lots of bots out there scraping Twitter and randomly clicking on links.
Yeah, so these numbers could be a lot off. We'd need to put in a lot more time to figure out how to prune them.
So some conclusions. There's already a lot of bots on Twitter, and just the task of collecting samples of tweets to train neural networks on is definitely not a trivial task. You can spend a lot of time building.
What's throwing us off a lot is something like 60% of the tweets are by bots, and most of them are very, very similar. So the neural network gets to copy bots a lot and gets to sound like a bot, which is exactly what we don't want.
Right. Training the networks takes a lot of time, so sometimes you'll just be waiting for the networks to train before you can really test anything.
Yeah, we had to manually remove all the hashtags from the tweets because the neural networks, for some reason, just love them. I would get a neural network just saying hashtag cybersecurity, hashtag hack, hashtag cyber, hashtag hard, hashtag Trump, hashtag. Yeah, and they even start repeating cybersecurity like 17 times in a row.
Yeah. It also depends on if there's big current events going on at the time too. Our first collection of tweets was right after the election happened. So
in 300,000 tweets about cybersecurity, Trump appears like 450,000 times, meaning basically half the tweets are about Trump.
Right. Which again is, I mean, I guess it could be good because you're generating tweets based on things that people are actually tweeting about, but at the same time, you want it to kind of be more general than that.
Mm. At least it's gonna pipe down in a month, so
right.
They're not gonna be good.
Right. Another point, machine learning is becoming really much easier for kind of the general hacker to use. There's really great open source libraries now for it. So I think we'll be, seeing these kind of methods becoming more and more popular to people without, advanced degrees in data science. And then we'll also point out that private accounts are immune to this sort of thing, since the Twitter API, you can't pull down tweets from those, you can't see those people's profiles. So as long as your profile is private, nobody would be able to try to attack you with something like this.
Although we technically can make a general purpose bot.
Next steps that we would take, create better and larger training sets. Again, you could spend a lot of time working on this. We could also use data science to pick more high-value targets. Right now, we're just picking anybody who's using a certain hashtag or something. So you could spend more time on picking good targets too. And then another point that they pointed out in the paper was that they used a user's Twitter history to see when they were most active on Twitter, and then tweet at them during those times. So again, a little bit more data science to try to increase your chances of getting a user to actually click on your link.
Okay, I think we're done.
Yeah,
That's
that's all we
just
have.
Linux. I guess thank you.
Thanks.